Today I'm gonna talk about the limit of indeterminate form infinity over infinity, and we're gonna use L'Hopital's rule to solve this type of form. Okay, so the first things I'm gonna introduce what is L'Hopital's rule. For the L'Hopital's rule, for example, when x approaches a, if fx over gx approaches 0 over 0 or infinity over infinity, then we have what? Then we have the limit when x approaches a, derivative of the numerator over the derivative of the denominator. So the key one is this condition. We call it 0 over 0 or infinity over infinity. Okay, and today we're gonna focus on infinity over infinity. Okay, before that I would like to recall some formulas. Okay, so the first one is derivative of constant equals 0. The second one, the derivative of x to the power n, that is n times x to the power n minus 1. And then we have a very special case, derivative x that equals 1. Okay. Third, the ln x. Okay, the derivative of ln x is 1 over x, and the easiest one is e to the power x. Derivative of e to the power x equals itself. And the fifth one, if we have a constant multiplication and of an function, okay, for example k is constant times fx, and if we do the derivative, we're gonna keep the constant and we only do the derivative for fx. So that's the 4 basic formula. I'm gonna use it during solving these examples. Okay, now let's take a look. The first example, we have rational expressions. Okay, and if we check when x approaches infinity, we can easily tell for the numerator that is infinity, and the denominator can easily tell that is infinity, right? Infinity. Now, so this condition is satisfied, infinity over infinity. That means we can use L'Hopital's rule. So we're gonna do the derivative for the numerator, and then we're gonna do the derivative for the denominator. Okay, and again then we can simplify it. For the numerator, we have 3 terms. Okay, we can use the sum rule. So if we do the derivative for this binomials, we have 3 monomials. So we're gonna do the derivative for each monomial. Okay, so for example, here we have 3 monomials. That means we're gonna do the derivative of the first term to x squared, and then we're gonna do the derivative of second term, and we're gonna do the derivative for the third term. Okay, and similarly, we're gonna use the sum or difference rule. We do the derivative for each monomial. Okay, the second term, 2x and plus 1. Okay, and now we can continue to simplify it. We're gonna follow the rules. And the 2x squared prime, so we can follow the formula fine if there is a constant. Okay, here the constant is 2. We're gonna keep the constant the same and do the derivative only for the fx, that is x squared. The same things. We have 3x. We keep the constant or move the constant out of the derivative. We only do the derivative for the x terms, right? And 1 is constant, so we're gonna follow the first formula, that is 0. And similarly, we have x squared, and for the denominator 2x, we have 2 times prime x and plus 0. And now we can have x approaches infinity. What's the derivative of x squared? We're gonna follow the power rule. So that should be x squared gonna be 2x because n is 2, right? What's the derivative of x? That is 1, right? This is 1, so which is plus 3. And similarly, we do the derivative of this x squared. We have 2x and minus 2 x prime is 1. Okay, so we got this one, and we can simplify it. 4x plus 3, and in the denominator we have 6x minus 2. Okay, so if we check this rational expression, when x approaches infinity, and this guy, the numerator approaches infinity, and again plug in x approach infinity, here we can see the denominator also approaches infinity. Okay, again it is infinity over infinity, so that means we can use L'Hopital's rule again. We do the derivative for the numerator, and we do the derivative for the denominator, and this one will give to you, we're gonna do the derivative for each term. Okay, now we can simplify it. So we have x approaches infinity, and here we have constant, right? Constant. We keep the constant the same, follow the rule number 5, right? And then only do the derivative for the x, and for the second term is 0. And similarly, for the denominator, we have 6x prime minus 0. Now we can simplify it. X approaches infinity. Derivative of x gonna be 1, so it's 4 over 6, and we can simplify it. It's 2 over 3. That's it. Okay, now let's take a look the second example. Still, we're gonna check the rational expression. When x approaches infinity, this term, the numerator, we can easily find that is infinity, and for the denominator, it's infinity. Okay, so that means we can use the L'Hopital's rule. Okay, L'Hopital's rule means when x approaches infinity, we can do the derivative for the numerator, and we can do the derivative for the denominator. Okay, and we have ln x prime follow the formula 3, 1 over x. And the denominator x squared prime, we're going to follow the power rule, right? We can easily get that is 2x. Okay. Now, here 1 over x, here is 2x, so we can simplify it. So we'll let the denominator divided by 2x and the numerator divided by 2x, right? 1 over 2x, 1 over 2x, and now we can simplify it. We cancel out, okay, cancel out this denominator, and we're gonna get x approaches infinity 1 over 2x squared. Now we can tell when x approaches infinity, that should be 1 over infinity. Okay, 1 over infinity means what? Means it equals 0. Okay, 1 over infinity equals 0. Now let's take a look the last example, and again the first thing we're gonna do is check the numerator and denominator when x approaches infinity, and then we can easily find that it belongs to infinity over infinity. So that means we can apply L'Hopital's rule to solve this limit. Okay, again we're gonna do the derivative of the numerator, derivative of the denominator, and for the numerator we can easily see the derivative of e to the power x gonna be itself, and the denominator is 2x. Okay, and again we can see here belongs to infinity over infinity. That means we can do the L'Hopital's rule again. Okay, we can apply the L'Hopital's rule again to solve this limit. Let's take a look. We do the derivative for the numerator, and then we do the derivative for the denominator, and we're gonna get derivative of e to the power x gonna be e to the power x. And the derivative of 2x, here's a constant, right? We can keep the constant. And the derivative of x is 1, so should be e to the power x over 2. That's it. Now let's take a look. Here is when x approaches infinity, ex approaches infinity, right? So it's infinity over 2. So that means what? That means this limit equals infinity. Okay?